Okay, we're gonna solve exercises that are gonna ask us to verify trigonometric identities. An example of this type of exercises is like verify tangent of x times cosine of x gives you sine of x. What's the process we're gonna do? We're gonna copy only the left side of the identity, okay? And we're gonna have to transform that left side into the right side. If we can do that, then we have already proven that the identity is true, because that's the only way an identity can be true. If it's impossible to transform one side into the other one, then that thing is not an identity. Now, how do we transform from left to right? We're gonna have to use other identities that we already know, okay? Other identities that we know are true. And which identities we already know? We already know these ones. These are the ones that are given, okay? And using these ones, we should be able to prove whether identities are true or not. So let's begin, okay? Exercise number 1, verify the identity sine times cotangent gives you cosine. So as the steps go that way, I'm gonna copy the left side, okay? I'm even gonna put that is equal to itself, because it's the same thing, so they're equal. Okay, that thing's given, and I'm gonna try to transform the left side into the right side. So my objective is to reach cosine of x, okay? How am I gonna do that? Substituting some stuff in here by using the previous identities I already knew. So I'm gonna do now is I'm gonna try to see if I can change something here. Okay, sine times cotangent. So what can I use that is gonna help me? I have cotangent as 1 over tangent, and I have cotangent as cosine divided by sine. I'm gonna use this one, not this one. You're gonna see later why. Okay, now this thing is a quotient identity, so that's the explanation I'm gonna give. Okay, I'm gonna use a quotient identity in cotangent. So sine x is gonna still be the same, but instead of cotangent of x, I'm gonna put cosine of x divided by sine of x, because that's what cotangent can be transformed into. Okay, the explanation is that I am using a quotient identity. Okay, now what happens with this sign and the sign that's under the line? Because they're in different positions, up and down, I can cancel them because they're multiplying with each other. Okay, so like sine is multiplying this parenthesis, and in this parenthesis I have a sign under the line, so I can cancel them. Okay. So in order to cancel them, I'm gonna put a line that explains I'm canceling. So that sign is going to cover sine of x and sine of x. Yes, so they're cancelled. Once they're cancelled, only cosine is going to stay there, right? So only cosine stays there. That means I have cosine of x. Okay, what did I just do? I cancelled sine of x. Okay, now I got cosine, and that was the right side of my exercise, so I'm done. I finished the exercise. The goal is that one, to transform the left side into the right side. I already did it. That's it. Okay, now let's verify another identity. Cosine of x times 1 plus tangent squared equals secant of x. So I'm gonna copy the left side, okay? That thing is equal to itself. My justification is that's given. Okay? I already know that thing is like, or I could even say like identity. Okay? Instead of given, I could put identity because that is a basic identity. Everything is equal to itself. Okay, every single thing is equal to itself. Okay, now I'm gonna start changing stuffs. Okay. So what can I change in here? 1 plus tangent of square, that kind of like looks complicated. And I'm looking for secant. Secant is the opposite of cosine, so maybe that cosine could be cancelled if I change something in this 1 plus tangent square. So let's try substituting that one. Okay, cosine x times, I don't know what that 1 plus tangent squared is, so let's look in here. Do I have a 1 plus tangent squared? Yes, 1 plus tangent squared is squared secant. Okay, so I don't even need the parentheses because it's only one thing. Okay, secant, but that thing is squared. My justification for that will be Pythagorean identity. Okay. Okay. If you notice that thing was squared, I can only use Pythagorean identities when I have squared or an even exponent. These ones, they don't have exponents, but I can still use them whether they have exponents or not. I would only have to copy the same exponent, and I can use them with any kind of power. So these ones, there is no problem using these ones that way. Okay, something kind of like to remember. So I have secant squared of x. This thing doesn't give me secant, but I'm kind of like close, right? Now, secant squared of x, or squared secant of x, I can transform that thing again. Okay? Or I could transform the cosine, for example. I don't know. You have two options in here. Let's transform the secant square, because transforming the cosine, yes, you can easily solve the exercise, but I want to prove that you can change these things even if they have powers. There is no problem changing them, so that's what I'm gonna do with that objective. You could change cosine and it's still okay. Secant square of x, like secant is 1 divided by cosine, so I could put in here 1 divided by cosine x. But because that secant is squared, then this cosine is also going to be squared. Okay, that will be using a reciprocal identity. Okay, now next, what happens with this cosine and the cosine square that's under it? We're gonna cancel, okay, but not completely, because this one is squared. So squared means that you have 2 cosines, but you're only gonna cancel 1. So in order to do that, put this line to explain that I'm canceling. And that same line, but not with the cosine, because Remember, the squared means that I have two cosines, so I'm only going to cancel one of them. If I cancel one of them, the other one's going to stay there, so it's no longer going to be squared. So technically, I'm canceling the fact that it's a square. So I'm canceling cosine with the second cosine that that you have in a square. Okay, so that will leave me with only one cosine under the line, sine of x. Okay, so what did I do? I cancel cosine of x. That's what I did. Okay, now what is 1 divided by cosine? One divided by cosine, if I check in the identities I have, 1 divided by cosine is seconds. So yes, I can copy them backwards and it's still okay. Puedo copiar uno a la otra. Like I could do whatever in whatever direction I could substitute them. So I'm gonna substitute, instead of this, I'm gonna put second of x. So that thing was second of x. What is that thing I just used? I used a reciprocal identity. Okay. See if I can put Pythagorean identity. Yes. Okay. And that's it. I already got the right side I was looking for, so that will be it with this exercise. Okay, let's see the next one. Okay. I'm trying to transform this thing into 1. Okay, that's my goal. So let's see if I can do that. So I copy the left side, okay, which is equal to itself. It'll be an identity. An identity, two things that are equal. These things obviously are equal because they're the same thing. And let's see what we can substitute here now. Yes? So let's see. What is tangent? Tangent. Okay, let's try changing tangent. What is tangent? Let's look for these things. Okay, I have a quotient identity that tells me the tangent can be changed with sine divided by cosine. So let's do that. Okay, tangent is sine x divided by cosine of x. Okay. What is cosecant? Okay. Cosecant of x. Okay, cosecant. I have one reciprocal identity that tells me that cosecant is 1 divided by sine. Okay, so cosecant, I'm going to have 1 divided by sine of x. Okay, and then I have cosine there, so I'm going to leave cosine that way. Cosine of x. And what did I do in here? I used quotient and I use a reciprocal, right? Yes. Use the quotient for tangent and a reciprocal identity for cosecant. Okay. So let's see what happens in here. Okay. You might see that I have sine under the line and sine above of the line, so they can cancel. And I have cosine under the line and I have a cosine outside above of the line because there's no line. Okay, so I can cancel cosine too. That will leave me only with 1 and that's it. Okay, so it's kind of like straightforward. So I cancel sine. Okay, cancel sine of x. I also cancel cosine with cosine of x. Okay. cancel sine and I cancel cosine. That will leave me only with number 1. What's my justification for that? That I cancel sine x and cosine x. Okay, and that's it. I got what I was looking for on the right side. That's all I have to do. Okay, that's how you verify identities. You substitute using these ones and you see what you can cancel and eliminate, or maybe get something different, so that you can step by step achieve your goal of transforming left into right. Okay, that's our goal, transforming left into right.